to one and all present here. Today we are going to discuss about some of the things in operating system. The movie of this PPT is this video is today we are going to discuss about the evaluation of operating system and operating system structures and operating system structures mean understanding the internal architectures of OS and tracking the hierarchical development of OS, how it's evolved from the previous to nowadays, how OS is evolved from beginning to right now. Operating system services, exploring the services provided by OS, and system call, what are the system calls available, examining the interface between the system calls means it is one of the interface between the user program and OS and the system program, identifying the program that supports OS operations and OS generations and boot, understanding the process of creating and restarting the OS. System starting program is known as boot BIOS, BIOS, basic input and output operations. Virtual machines, exploring the concepts of running multiple OS on one single machine. This is the concept of virtual machines. Virtualization types, differentiating between the various virtualization technique. This will be full virtualization, para virtualizations. That and all we will discuss in this video. Hypervisor, understanding the role of hypervisor in virtualization. These are the topics we will going to discuss about in this video. This structure, this photo is created using the napkin.ai. Let's discuss about one by one. Operating system overview. An operating system is a software and it is act as a interface between the user program and hardware, and it manages the hardware and software resources. It provides services for application program. What is the objective of the operating system? It is convenience, that is make computer easy to use, and efficiency, that is maximizes the resource utilization, ability to evolve, support new features also, and security and protection. These are the objective of operating system. For that only operating system is found, and all the systems we are using have mainly operating system. Without operating system we cannot run the applications also. This is the functions of operating system. What are the functions means? Process management, memory management, file management, IO and device protection and security. These are the main functions of operating system. Process management means creations and scheduling and termination of the process. Memory management means allocation and deallocation of our process into the memory. And file system management, file may be opening and closing and allocations of files. And IO and device operation, what are the IO devices are needed at the time of processing. These all the operation, protection and security. Maybe some files may be opening and some files may be closing, and who can use, who cannot use, and how it is opening, in what way, and what are the role it is used. Maybe is some system admin, if they are want to open the applications mean, it may be run, it may be what are the based on the role, maybe admin or user. So based on the role, some of the things will open, some of the things we cannot show to customers. Like that, security also provides. These are the operations given by the operating system. Evaluation of operating system. And operating systems evolve with hardware development, improved efficiency and user interaction, moved from manual operation to automation. Batch operating system, jobs collected, executed in batches, no user interactions also there. High turnaround time. Example, early IBM systems developed were using the batch operating system. Multi-programming operating system, multiple programs in memory, CPU utilizations improved, reduced idle time, it gives better throughput, that is number of process completed per unit time is throughput. So we are using multiple programs at a time, multiple programs at memory, so CPU utilization is improved and idle time is reduced, so better throughput is received. Time sharing operating system, multiple user interact simultaneously, CPU time shared using time slices. Quick response time, example Unix, multiple users are interacting simultaneously, CPU time is shared between the time slices, so it is known as time sharing operating system. At a particular time one operating system is, one user is used, another particular time another user is used, like that time is shared between the different user. Quick response time, example is Unix. Unix is one of the multi-user time shared operating system example. Distributed and real-time operating system, distributed OS, multiple systems are connected, resource sharing across the network. Real-time OS means strict time constraint used in medical, defense, robotics, what in the medical industry or industrial, wherever the time is mainly needed at that time, is time constraint that OS, this is known as real-time operating systems. Operating system structure, organizations of OS component improves the reliability and maintainability. For this, many of the operating systems, I already shown some of the architectures of the operating system. All the operating systems have basic fundamental hardware at the bottom layer and OS is layer between the hardware and software. And software means system software also there, system programs also there, and on the top of that only application programs are built and users are accessing that via these are the operating system means. In the structure itself, monolithic structure is there and microwave kernel applications also there. We will discuss one by one. Monolithic structure, single large kernel. This single large kernel itself doing all the functional, all the services in the kernel mode, fast execution, difficult to debug. We cannot find where the difficult has occurred because all the things are monolithic only. So single large kernel is doing all the workers, all the services are running in the kernel mode, fast execution, difficult to debug. And layered architecture, OS is divided into some of the layers. Each layer uses the services of lower layer functionalities and easy to debug because of each single layer has one, each OS single functions is slower than the monolithic structure. Microkernel structure, minimal kernel, services run in user space. In monolithic structures, all the services are used in the kernel space. Here, user space. So high reliability and security. Example Mac. Mac OS is used in the Apple. So this is so most of the work is done by run in the user space only. Services are running. Minimal kernel. So security is improved, high reliability. Operating system services, programming, execution, IO operation, file system manipulation, error detection and resource allocation. These are the services provided by the operating system. Program executions, program may be loaded, unloaded, allocation and deallocation, IO operation, read, write, all the things, and file system manipulation, file may be opening or closing. If any error occurs means error detection, and resource allocation for one process. How many for one process itself? It may be required some of the IO devices. So all memory, all the allocation works are done by the and managed by the OS. Users and OS interfaces, command line interfaces, CLI. We are giving command and executing that command by means of only we are getting we are interacting with the OS and all the functionalities, whatever what are the programs or applications we can we can run by command mode. That's called command line interface. In graphical user interface also there, in graphical we are having many menus, and using that icon based we can understand easily. So wherever the menu by means of close button or open, like that we can see, we can interact with the operating system. And touch based interfaces nowadays came, all are now using the smartphones, touch based screens. Even laptop also have the touch screen, mobiles also have the touch screen. So all you know, system calls, interface between the user programs and OS. How we can interact with the OS by means of only system calls. Invoking using API runs in kernel mode only. System calls are runs in kernel mode. Types of system call: process control, file management, device management, information maintenance, and communication. Process control, file management, device management, information maintenance, and communication. These are the types of system calls. System programs provide convenient environment, file management utilities, program development tools, system status utilities, that some of the clock, like the timer. These are the programs we are using day by day. These are comes under the system programs. And OS generation: first generation computers are used in vacuum tubes, and second generation computers are made by transistor. Third generation's computers used ICs, and fourth generation computers are fourth person computer. Every computer has OS: system boot process, power on, bootstrap loader execution, and kernel loader into the memory. System services are started. Before starting our system, some of the programs are running now. That's called system booting. Bootstrap loader only execution. Virtual machine software emulations of physical computer and runs multiple OS, provide isolations and security. So we can run more number of users between one user, one process to another process. High isolations is there, so security is improved. We can run multiple OS. Technology to create virtual resources, improve the utilizations, and support cloud computing. Types of virtualization: full virtualization, para virtualization, and hardware assisted virtualizations. Hypervisor: software that creates and manages VMs. Type 1 bare metal and type 2 is hosted. Examples of a hypervisor is VMware ESXi, Microsoft Hyper-V, Gen, and VirtualBox. Operating system manages system resources. It provides services to users and applications. Visualizations enable efficient computing, foundation for modern computing systems. Evaluation of operating system. The evolution of operating system reflects the growth of computer hardware, user requirement, and application complexity. Evolution of operating system has moved from simple job execution to highly complex system capable of handling multiple user devices and application efficiently, forming the backbone of the modern computing environment. The operating system has evolved continuously to meet the increasing demand of users and advancement in computer hardware. It can be broadly classified into the following stages: serial processing, no operating system used and only one program is executed at a time. CPU utilization is very low. Batch operating systems, and then came jobs with similar requirements were grouped and executed in batches, so no user interaction during the program execution. That is, one batch is running, after we are getting the result out, after that second batch is executed, like that. Between the one batch may be contain 10 or 20 process. Between the one process to another process we cannot interact. And multi-programming operating system, multiple programs were stored in memory at the same time. CPU switches between jobs to improve the utilizations. Multiple serial processing, batch operating system, and multiple programming operating system, and time sharing operating system. Many users share the CPU simultaneously. Each user gets a fixed time slice for quick response. One user is used at another time, another user is used, so every user is getting time, getting the response. If one user is waiting, another at the time it process the another user program. And real-time operating system task must be completed within the strict time limit used in embedded and control systems, that is in industrials, in embedded, and that is nowadays we are using most of the equipment, that is fridge, micro oven, heater, what cookings in industrial, and then many have time constraints ways only. Distributed operating system, multiple computer work together as a single system. Resources are shared to improve the performance and reliability. Network operating system, systems are connected through a network for resource sharing. Each system runs its own operating system. Modern operating system supports multitasking, multiprocessing, and GA. Focuses on security, visualizations, and cloud computing. What are the advantages of operating system? Operating system manages external and internal devices, for example, printer, scanner, and other devices. Operating system provides interface and drivers for proper communication between the system and hardware devices, allows multiple applications to run simultaneously, manages the execution of processes, ensuring that the system remains responsive, organizes and manages files on storage devices. Operating system allocates the resources to various applications and ensure their efficient utilization. What are the disadvantages of operating system? High resource usage. Operating system consume large amount of CPU, memory, and storage. Complexity. OS design and management are complex and difficult to understand. Security risk, vulnerable to viruses, malware, and cyber attacks. System failure. If the OS crashes, the entire system may stop working. Cost. Some operating systems are expensive and require licensing fees. Performance overhead. OS management task may reduce the system performance. Compatibility issues. Some software and hardware may not work with all operating system. If you are using the 32-bit, means you have to put the 32-bit OS. If you are having 64-bit, means 64-bit operating system, you should install. Like that, some hardware compatibility and software compatibility is required. OS simple structure, for MS-DOS is example one, and monolithic structure Unix, and layered OS DOS, and microkernel Mac OS, modular Linux, virtual machines VMware, client server architecture Windows NT. We already saw what are the structures are available. User and operating system service. The operating system interface allows user to interact with the operating system and request these services. It acts as a bridge between the user and computer system. What are the types of OS interfaces? Command line interface, graphical user interface, touch user interface, and voice user interface also there. Command line interface. The user gives instruction by typing commands using the keyboard. The system performs the action based on the typed command. It is fast and powerful but requires remembering command, mostly used by programmers and system administrator only. Example, MS-DOS and Unix shell. We already saw what are the basic Unix commands are there in lab program that comes under the command line interface. And graphical user interface, the user interacts using the pictures such as icons, windows, menus, and mouse. Easy to use and does not require memorizing the commands. Suitable for beginners and general users. Uses more memory compared to CLI. Windows, Mac OS, Linux, some flavors are there, Ubuntu. These comes under the graphical user interface. And touch user interface, the user interacts by touching the screen using fingers, supports actions like tap, switch, and pinch. Commonly used in smartphones and tablet. Simple and fast for mobile devices. Example, Android and iOS. Voice user interface. The user interact with the system using voice command, useful for hands-free operations and disabled user. Require good voice recognition technology. Example, Siri and Google Assistant, Alexa. These are voice. Menu-driven interface. The user selects commands from a list of options, menus, easy to use and reducing typing error, common in ATMs and embedded system, ATM machines, washing machine. Conclusion. User OS interfaces make computer easy to use by allowing the user to communicate with the operating systems in different ways based on their needs and device types. User interface may be CLI or GA or touch, voice, operating system, hardware. System calls are a special functions that allows a user program to request services from operating system. They provide a controlled way for program to access hardware and OS resources. Why we are using these system calls? System calls why we need. User program cannot access the hardware directly. Main thing. User programs cannot access the hardware directly. System calls access a bridge between the user mode and kernel mode. They ensure the security and controlled access. The types of system call: process control, used to create, run, and end processes. Example, fork and exit. These are the system calls used in process control. File management, used to create, read, write, and delete files. Example, open, read, write. And device management, used to use and control hardware devices. Example, read, write. Maybe here also we are using why means read from which device. That's all. Read from or write to which device. So device management also have read and write. Okay. Then information maintenance, used to get or set the system information, get PID, time, like that. Communication used for data exchange between the processes, pipe, socket, port, like that. No? These are the system calls used for communication. Protection, used to control access permission, CH mode and CH one. CH mode used for changing the mode of operation, whether write, read, or execute permissions we are giving for individual or group, like that. Okay. System programs are utility programs that provide a convenient and environment for users to develop, run, and manage applications. They are not part of the kernel but work closely with the operating system. Types of system programs: file management programs create, delete, copy, and organize files and folders. Example: File Explorer, LS, CP. These are called as system programs. Status information program shows system informations like date, time, memory, and CPU usage. Example: Top, PS, Task Manager. These are programs also system programs. And file modification programs edit and modify file content. Text editor like Notepad, VI. Programming language support provides tools like compiler, interpreter, and debugging. Example: GCC compiler and Python interpreter and JDK also. Like that. Program loading and execution. Load program into memory and run them. Example: loader, linker. Communication programs enable communication between the user and systems. Example: email, FTP, browser. Background services run continuously in the background to support system operations. Like example, printing services, network services. OS generations explain how operating system developed over time along with computer hardware. First generations computer we already discussed. No operating system was used. Programs were written in machine language. In second generations from 1955 to 1965, simple batch operating system were used. Program used assembly language. Third generations multi-programming and time-sharing systems developed. OS supported multiple users. Fourth generation from 1980 to 2000, like that. Present personal computer and modern operating system, GUI, networking, security, multitasking supports. System boot. System booting is the process of starting a computer and loading the operating system into the memory. What are the steps? We already discussed. Power on the system and BIOS, basic input output system. UEFI checks hardware post. Bootloader is loader. Operating system is loaded into RAM. User interface is displayed. Types: cold boot and warm boot are there. Cold boot means starting from power off. Warm boot means restarting the system. Two types of booting are there. Conclusions: operating system is a software that manages computer hardware and software resources. It acts as the interface between the user and the computer and allows program to run. What are the operating system example? Windows, Linux, Mac OS, Unix, like that. Kernel is a core part of the operating system. It controls the CPU, memory, devices, and handle the system calls. Kernel is the heart of OS. You should know. Unix is a powerful multi-user multitasking operating system developed at AT&T. It is mainly used in servers and workstation and follows a command line interface. Example: Solaris. Linux is a free and open source operating system inspired by Unix. It uses the Linux kernel and is widely used in server, desktop, and mobile system. Example: Ubuntu. OS complete system software. Kernel core of the OS. Unix a type of operating system. Linux an open source Unix like operating system. Thank you for all. If you are having any doubt or any clarification you need, means you can just comment. Thank you for all. So in this presentation we came to know what are the operating systems are there, how we can run from why we are moving from one operating system to another operating system, what are the evaluations are there, like that, what are the system calls are there, and what are the objective, all the things we discuss. This is the overall overview of operating system. Thank you one and all. If you are having any doubt, means you can comment. Thank you.